the post-assessment is already available in School City, but you can work on this preview. You can work on the PDF file every day a little bit, and work a little bit today, a little bit tomorrow, and after tomorrow, you on Friday, you input all your questions, all the answers on School City. My proposal, my offer is that if you have 75% or more, I'm repeating so you can really understand this offer. I think it's a good offer. You will have 100% grade, not in one testing, but in all the tests. All the tests of this fourth quarter. You don't need to be worried about tests anymore, as long as you have 75% or more on this post-assessment. You just have to complete the couple of quizzes every week to have, at the end of the fourth quarter, an excellent grade. As long as you are on grade level or beyond grade level, that means 75% or more on the post-assessment. Okay? If you don't reach the 75%, not a problem. This is not a problem. Let's say you get 74%. I can give you an extra credit if you submit before the due date. So maybe this will go over to 80 or a little bit more than 80%. And you still have the testing from May 21st to get a good grade. If you didn't complete yet, you still can work on April 13 to have a good grade. And then you combine all the grades from the 3 tests, and you still can have an excellent grade for the fourth quarter. But it's more work. You have to work on more tests, right? I think it's a good offer. Take advantage of it. Work on this post-assessment as soon as you can. And on Friday, we don't have meeting. It's going to be a testing day for us. I will help you with any technical difficulties regarding School City, regarding inputting your answers on School City. All right? Any questions? If you don't have any questions, just keep in mind to take this chance to grab this opportunity and guarantee an excellent grade for this fourth quarter. Let's move to the topic of today's class, but before, a quick review and the yesterday's. Yesterday, we learned how to graph exponential functions. It was actually also a review. And the main, we have 2 different kinds of exponential graphs. The main kinds of exponential graphs. If it's going like this, like it starts with a very high value, all the way to infinity, to y equals infinity, and comes down very quickly. This is coming down, 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 down very quickly. And at this point, it slows down and gets closer to 0, and then goes all the way to x equals positive infinity, trying to reach 0, y equals 0. Okay? This is called decay. This is an exponential decay, and we will find this kind of graph if b is less than 1, right? And the other kind of graph is this. If it starts, is the other way around. If it starts closer to 0, and then it grows, raises just a little bit, very slowly. At this point, it grows faster and faster and faster, and grows even faster, and goes all the way to infinity real fast. And this is called exponential growth. And we will find this kind of graph when b on the function, b is greater than 1. But wait a minute, b is missing. I cannot find b of this example, and I need you to help me. What is going to be the value of b? Hence, if you want to find the value of b, this is the function, the growth function, right? This is the growth. You make x equals 1, then you find the value of y for x equals 1. The value of y will be equals to the value of b. Can you find out? Can you help me? Can you check what is this number that's missing? Thank you, Leonardo. Thank you very much. Let's think. This is a growth, so it's greater than 1. We know that. We check, we make x equals 1. So if we have x equals 1, the function of x or y is going to be equals to the number that's missing. And y is, if x equals 1, y equals 2. Yes, 2 is the right answer. Excellent. Thank you, Raymond. Nice. Again, thank you, Raymond, and thank you, Leonardo. Thank you both. F of x equals 2 exponent x. That is the right answer. Very good. Excellent. Let's move on. Because I know you are capable of graphing exponential functions. You are capable of finding a point on the graph and finding the value of b. Now let's move on to the next topic. Let's work on solving exponential equations. All right? And solving exponential equations. There are a few methods of solving exponential equations. One of the methods applying a logarithm function. But we're not covering logarithmic functions. Let's focus on this method here. And check the example. If we have 5 exponents to x equals 125, to solve it, we will try to make both sides of this equation to have the same base, right? If the left-hand side, we can see it has the base 5, the base is equals to 5. Let's check if we can make the other side of the equation with the same base, 125. The other side is 125 exponent 1, right? Can we represent 125 multiplying 5 a bunch of times? That is the question we need to answer. So let's try. 5 times 5 is 25, times 5 again is 125. That means this 125 is equals to 5 times 5 times 5, 5 times 5 times 5, which is 5 cubed, right? Now we can make the comparison. We can compare 2x with 3. 2x needs to be equals to 3 because they have the same base. 2x equals to 3. Divide both sides by 2. X equals 3 over 2. That's the right answer. Now, do you have any questions? We will try to use this method to help solve the bell work, okay? And also, we're going to apply this method to solve all the questions on the quiz. Let me know if you have anything, any question about this, any step you didn't understand. My suggestion to solve this, we will need to simplify this equation. So find 2 exponent 0. Every number, if you have any number exponent 0, is equals to 1. So 2 exponent 0 is 1, right? The only exception is 0. 0 exponent 0 is undefined. But 2 exponent 0 is 1, plus 2 exponent 1 is 2, plus 2 squared is 4, and 2 cubed is 8. Now the other side of the equation, 3 exponent 1 is 3, and 3 squared is 9. And then we have 3 exponent x. Okay? Now, next step. Let's simplify, add together 1 plus 2, 3, plus 4, 7, plus 8, 15. 15 equals 3 plus 9, 12, plus 3x. Nice? Move this 12 to the other side, becomes a negative 12. Negative 12 plus 15. So 3 exponent x equals 15 minus 12 equals 3. We have the same base 3 on both sides, and the exponent on the other side is 1, right? Now we can compare the exponents. We can say x equals to 1. So the right answer is x equals to 1. X equals to 1 is the correct answer. The same method we're going to apply on the quiz. And we have 4 exponent 3x plus 5 equals to 16. We can represent 16 as 4 times 4, right? 4 times 4 equals 16. And 4 times 4 is 4 squared. So we can compare the exponent 3x plus 5 with the exponent 2. So 3x plus 5 equals 2. Move this positive 5 to the other side, becomes a negative 5. 3x equals 2 minus 5. 3x equals negative 3. X equals negative 1. And do the same thing in each question. We have to try to change, and all the questions here is going to be the right hand side. I think all or most of the questions you have to change the right hand side of the equation and make it have the same base as the left hand side of the equation. Okay? For letter B, well, we have to find. We have 5 exponent 7x equals, well, we need to find if we can represent 625 as a multiplication of a bunch of 5s. So let's try. 5 times 5, 25, times 5 again is 125, times 5 again is 625. So this is equals 5 times 5 times 5 times 5, right? 4 times. So this is 5 exponent 4. Compare. 7x needs to be equals to 4. X equals 4 divided by 7. 4 over 7. That is the answer. Okay? Now, letter C. This is interesting because now I have this fraction. 1 over 1,331. The first thing, check. This side we have 11, right? The base 11. Let's check if you can represent 1,331 using base 11. Multiply 11 times 11, oops, times 11 again, and you will have 1,331. So this is equals 1 over 11 cubed. But you can represent, when you have something like that, you can move the denominator to the top to the numerator by changing the sign of the exponent, make the exponent negative, right? So you can say 11 negative 3x equals, and then move to the numerator 11 and change the sign of the exponent, negative 3. Now that's okay, we can compare the exponents, and we have negative 3 times x equals negative 3, x equals 1. Right? Thank you, Leonardo.